Okay, there we are. It's official. Lecture 31. And we're going to cover a bit of a surprise. It was on the syllabus, and I took it off and I put it back on again. I'll kind of explain, but we're going to primarily cover regular expressions today, and I'll kind of give my rationale for choosing that here for our last big lecture. Let me actually load the linked file. Actually, I'll wait on that. Take back until we get to closer to our first exercise. Then I'll have to repost it multiple times. I expect we'll get a few more folks joining. Okay, yeah, so here's where we are. We were going to do software patterns this week, predominantly today, and I really was quite looking forward to that, but it's just too much too late. I was trying to find a way to introduce it. I think it's an important concept. I might take a little bit of time on Thursday, really just to arm you with an understanding of what it is and where to go to find more. We can have a light dialogue about it, but I'm not going to put it on any of the tests, or I'm not going to put it on the final exam. So don't have to worry about that, but it is a good topic. Instead, we're going to cover regular expressions, which we will have a few questions or one question on the final exam, and you'll have an opportunity to practice those questions as well. So that's kind of the outlook. And then I apologize for being frustrated with people today because for some reason I thought homework 9 was due when I got up this morning. I thought, God, I can't believe nobody actually turned in their homework last night. I was like, man, they've really checked out. I think it was kind of me that had checked out. So anyway, obviously you've got a little more time on that. So let me know if you have questions. And then, so for today, we just kind of want to go over these quick announcements, remind some folks of stuff. Sorry, text got hammered there. Quiz 7 is an optional ungraded quiz. And then quick review over the stuff we covered on Thursday from error handling. And then we'll talk about regular expressions, which I think is a good topic to leave you with in the course because it is actually very much a cross language concept. If you go to other languages, there's a very good chance you're going to run into it again. So I think it would serve you well to arm you a little bit with an understanding of it, even though some of the things we'll learn will be C++ specific. But it's a very, very common mini language all to itself. And so I think it's good to get you a little bit of an icebreaker on that. So homework 9 due next Monday. Homework 10, again, that's optional. It's not on Canvas. I would appreciate it if anybody who is contemplating that would email me and let me know about that. I just kind of want to get a list of names so I know who to watch out for. And then at some point I'll post a place for you to submit it, but I would just like to talk to people and just get a sense of what their idea is when you decide to go after it. Nothing too serious, but again, that is an option for dropping your lowest homework grade. Homework 7 is not graded. It's another one of those collections of things that happened since our last quiz. You have 3 chances to try out all of these subjects. And this is really just to help you on the final. And you'll get 3 shots on all of the recent material. So, and then you'll see that again on the final exam practice. So what is in quiz 7 will definitely be represented on the final exam practice and on the final exam. So you should get a lot of repetitive exposure to the kinds of questions on the final that from our most recent material. And also, so final exam practice is out now. It's not quite 75 questions. I came up a little bit short in trying to get everything put together on time for today, but it's about 70 questions. And so you'll get a pretty good sense of what is going to be on the final exam. The only things that are missing are kind of earlier term foundational questions that I think probably most everybody knows. I just didn't get a chance to get them all copied into the practice exam. So I think you'll be in pretty good shape. You'll have 1 shot on that. But do remember that you can go back and still, I believe you can still go back and use up your remaining attempts on your quizzes. You can't improve your grade on your quizzes, but if you feel like you want to go back and practice some material from quiz 6 or quiz 5, if for some reason you didn't take all of your chances, your 3 chances on those, you can go back and still do that. So that can be a useful study strategy for the final exam if you want to go there. I will need to, at some point, come back and adjust your quiz grades because unfortunately, Canvas makes it really hard for me to lock the grades off for the quizzes and yet still let you use up your extra tries. So if you do go back, just be aware if your grade goes up, it is only temporary. I will have to go back and tweak your quiz grades. So the good news or the bad news is quizzes don't count significantly toward your final grade. It's only, is it maybe true? To check the percentage, sorry, but it's not significant. So you're not gonna, if you're worried about being on the threshold with your grade, you're not gonna affect it that much. The other thing you do is just not submit the quiz, and you won't affect your grade in any bad way. If you do a very bad job on the quiz, you won't affect your grade anyway because it's going to take the highest score. So anyway, enough on that. I just wanted to make sure nobody got surprised there. Any questions on the announcement stuff or availability? Has anybody checked yet to see if those things posted? I had them set to post for 5:40 this afternoon. Let me know or just text the class if you happen to see it.
Yeah, I'll check right now.
Yeah, just pop something in the chat there if anybody sees it. Thanks, I appreciate that. Okay, just very briefly, because we got a lot of slides, but not a ton of material. But last time we talked about error handling. We talked about CERR, which is just a way, it's like a cout for errors, and we can redirect that to a file. And then exit, we said was a very unglamorous way to leave our program from just about anywhere. So we can print a message, and then we can exit with some unsigned integer value to give some hint to the calling function or their operating system or to us as we look at the console to see maybe a reason why exit happened. Exit's not a great way to leave a program. Some organizations strictly prevent you from using that code, but you can do it, just so you know. And this redirection thing, if many of you have worked on the command line much, you'll know you can do that. Of course, you can redirect output, standard output also. But the ampersand greater than also redirects the error stream, which is very handy actually for bifurcating those two kinds of messages. And then we talked about asserts, and there are two kinds of asserts. The traditional one is a runtime assert. An assert is where we say something we know to be positive and true, rather, and then if it fails to be true, then we'll exit from the program immediately. And then there's a little hack trick where we put the ampersand pointer is null on there just to give ourselves a message, because the old traditional assert doesn't allow us to do that. But if you force that in there, then the compiler will print that out, or the runtime will print that out when it crashes, or asserts rather, and then you can get a sense of which assert you got rid of. And because there's a cost, a performance cost with asserts, you tend to want to have them in there like scaffolding. And one way to do that and have it elegantly removed is use the if-defs and a debug statement. But if you do that stuff a lot, I've seen some ugly, ugly code where people just leave tons and tons and tons of if-defs in there. They really shouldn't be in there for a super long time unless you're really caught between a rock and a hard place and you ran out of time before your code had to ship. But it's good to know you can do that if you need to. Okay, so that's a runtime assert. Static assert is stuff you can test at compile time, things that are basically constant values. And the static assert comes from a library, and it has a more formal second parameter, right? So we talked about that a little bit. Same kind of idea, just the things that we test have to be constants, okay? Evaluated at compile time. And it can be put in any scope, which is nice too, right? So you can test values or very, inherent intrinsic values, above main if you want to.
Professor?
Oh, yes.
Before you continue, I think your mic is caught in your sweater again.
Oh,
Jackson pointed that out. Yeah.
I'm wearing, thank you. I am sorry about that. I'm going to remove that. I thought sweaters might actually be a not good prop. Indeed they're not. Okay, so thank you for that. So exceptions, try, throw, catch. We were saying that if you have a try block, you can throw an exception from within inside of there. You can also nest try blocks inside of each other so that when you throw an exception or you raise an exception and it's all very type-based, we can catch that either in the catch associated with the inner try block or a catch on the outside, right? And so we have to catch based on a particular type. And often we said we would rather throw an instance of a class because it gives us a lot of packaging to put data in there that we can interrogate in our catch to decide maybe what happened or how to recover. The key thing to remember about raising exceptions, the whole point of this, you might say, well, why don't we just assert or why don't we just exit? Well, we're trying to recover from a situation that is typically very difficult to recover from, either because we're deep inside of a library, or we don't have access to a user to ask them for guidance or to re-input a value. And because we're jumping out of the program flow, our scope is going to change. And so when we throw an exception, we'd like to package it in a class, because that class is going to be a copy of an instance, and it contains everything we might need to decide how to proceed. Imagine if we were throwing a pointer to some piece of memory that only existed in the scope of the inner try block. That stuff would go away potentially if it was on the stack, and then we crash in our catch statement. So we tend to throw an instance of a class so we can package up and move information out of the inner scope out to where we're going to deal with it in some outer catch area. Okay. And very often we just, we catch multiple catches at the very base of an associated try block, right? The throw might be buried inside of a function call, as we saw, but we typically have the catch and the try kind of together, right? The ones that are associated. All right. So you'll definitely see some questions like that in this quiz 7, and there will be one of them on the final exam. And do remember that if you don't catch a throw, you can certainly throw, sorry, an exception without catching it, but you will exit the program. In that case, it's almost like an exit or an assert, right? The other thing to really remember is, and this probably will get forgotten, so please try to remember this, because what we're trying to do is recover. The execution continues from where the throw was caught. So if I throw an integer here, execution of this particular code is going to continue from after that catch. It's not going to exit the program. It's going to continue from the next executable line after all the catch sections. So if there's a bunch of catches right here and it executes the int catch, it's not going to catch multiple catches. It's going to jump to the next executable line of code that's below it. So you will see a couple test questions like that. And I think you'll get it once you look at it. You'll have time to look over that, obviously. And then we mentioned throwing an instance of a class, and we tried something a little bit fancy. We created a templated sum of products so we could have a templated vector type. And then we threw an instance of a class. So here we're just on the fly calling the class name with its constructor, and it's creating a transient instance of the myException, right? We could have created, A equals myException A equals, and then call the constructor that way, and then throw the instance there. But it's going to make a copy of the instance so that it's not depending on any local memory, right? So that's the important thing I was mentioning on the previous slide. All right. So, and you can design your exceptions any way you want, but we also mentioned that you would tend to derive them or inherit from the base class, the STD exception type. Okay. So that was kind of the key points. Any questions on that stuff? Okay, cool. All right. All right, well, let's talk about regex, which is part of the regex library. Just curious, feel free if you want to put your hands up. I'm curious if anybody's ever used or heard of regex before. Cool.
Replacing text?
Yes, yeah, a pattern matching, and then potentially using that pattern match to replace text. Yeah, there's a whole lot of applications for it, but at its root level, it's a pattern matching. And I have to check the algorithm, but we covered, for those of you who were in the algorithms class last semester we covered a couple interesting pattern matching algorithms, and this probably is based on one of those foundational ones, or maybe something a little more hybrid. But we'll talk about kind of high level how you utilize the language with regex, not so much the algorithm for our class here. So here's a quick overview. So the idea is it's a pattern matching language, really. It's kind of a language inside of a language. So C++ is our language. Regex is its own language. And although there are slight variants, it exists all over the place in many other programming languages. You'll find it in Java, Python, Ruby, JavaScript, C++, and then even grep, if for those of you who are kind of Linux or Unix jockeys, you can utilize it there too. So if you learn regex in some semblance, you carry something with you regardless of which of these languages you go to. And although one of the senior engineers I work with felt like this was his favorite ninja interview question, and I thought that was a little bit over the top. A number of people do look upon regex as a differentiator if you know anything about it. So if you can remember one or two basic things for a job interview about regex, you win a few brownie points for that, I think. So the idea with regex is we have a pattern string that we want to apply to a subject string. And that pattern string can be, an actual word, like I'm looking for the word needle in, needle in a haystack sentence. So the pattern would be needle and the subject string would be needle in a haystack. Or it can be something a little bit more elaborate, like you could have wildcard characters in there, which some of you may have used, again, working in Linux or searching for files. We use a star character depending on what kind of extension the file is that you want. So that's kind of a pattern, right? It's not the exact name of the file, but it's kind of what you think it was. And so that's what regex does for us. So we can ask a couple of questions. We can say, well, does a given pattern exactly match a subject string? In other words, if I say, well, the subject string is a phone number, and then I have a pattern that describes the structure of a phone number, I can basically say, does this pattern exactly match this phone number subject? And that's an interesting thing to know, because then you now know, okay, well, that subject is an actual phone number or a credit card number or whatever, social security number. But we can also ask whether a pattern is found partially inside of the subject. So I could say, hey, is this small pattern somewhere in this very giant book of text? And potentially also, how many different times can I find this pattern in this giant book of text? So a more nefarious example would be somebody scanning through your unencrypted email and searching for credit card numbers, or through, troves and troves, terabytes of unencrypted emails and looking for a pattern match against credit card numbers, right? So if you, find yourself typing your credit card number in your email, you'll see today, it's not hard at all for somebody to write a program that just sifts through all that stuff. The pattern would be the phone number, and the subject string would be all of the emails that they could find concatenated together, right? So that's something called what we'll refer to as a search, right? And then if you want to sort of get more information about all of those things that got found in the emails, let's say all of the different credit cards that were found in all of the emails that were hacked, then we can actually use something called an S-match, which we'll talk about, it's just a structure. It's a class that allows us to interrogate what got found in a more optimal way. So all of this stuff is possible with the regex library. We'll look at it. And I'll talk about the bindings that are C++ specific, but what we're going to focus on, the part that I think you can take with you even beyond C++, is the mini language itself. We're going to spend most of our time today just getting to know the pattern matching, because this is the real barrier, I can tell you. If you can't get over this language, and how it works, it doesn't really matter how well you end up learning the bindings in C++. It's just daunting, and you can't hardly force your brain to do it when you need to learn about it. So here's just a visual example for those of you visual thinkers. So we have a subject string, and it might be quite long or it might be kind of medium size. And then we have some pattern, and that pattern we'll see can be expressed in structured ways. It doesn't have to be the word birth on birthday. It could be B and then 2 wildcard characters and then TH, for example. So that's our regex pattern. And when we talk about regex and regex objects in C++, the regex object is the pattern. That's one stumbling block for a lot of folks. The string is just a text string, right? It's the thing we're feeding into this pattern match thing, right? So we're really feeding that very simple text string through this regex instance. It's really an instance of a class that we've initialized or constructed using some specific pattern. So when we say the regex object, we mean an instance of the regex class. So we can ask questions like, hey, does that pattern there, does this pattern exactly match the happy birthday string? Nope, nope, does not. And that's what regex underscore match function tells us. We'll learn about that. But we can also ask, does that pattern match, starting from the beginning of the string and traveling through it, does it match anything partially? And that's what the regex search method will tell us. So we have 2 different methods in C++ that'll tell us 2 different things. One, an exact match, which is the regex match. And the other one is a partial or a search match, where we just move through until we find something that fits this particular pattern, which again could be a phone number, credit card, or as we'll see many other examples. Okay. Some people write compilers in regex, just so you know. You can go absolutely insane with this idea if you want to. So here's a couple examples. In a galaxy far, far away, we can search for far, and we'll get a match right there. That blue line is a little bit long. So is it an exact match with the subject? Nope, it's not. So we get a false back from the regex match. But if we search for a partial match inside of the subject, we get a true. And if we ask, if we interrogate and say, well, what was the thing that matched? It's going to give us back far. Now you might say, well, why do I need to know what I got back? Because I know what I asked for, it's far. But if you had F wildcard R, you don't know if it's for or far. And this response will tell you which thing got matched against a more general pattern, or a more cryptic pattern. Does that make sense? Everybody got that all right? Okay, let's look at one or 2 more, and we'll play around with this a little bit. So here's a phone number, right? And we'll explain what this means, but this is your first sign of kind of how cryptic things can get. So our pattern here is saying, hey, I want something in the range of 0 to 9, and then I want it a certain number of times, potentially. So that plus symbol, it describes what came before it. Very often in our regex patterns, as we'll see, we express one single character, what it might be inside of the bracket. So this, even though that looks like a range, it's just saying, hey, I'm looking for one character that might be in the range of 0 to 9, and I want it, as we'll see, 1 or more times. That's a special character we'll talk about, right? And I don't expect you to have known that now, but that's really just matching the 1 right there, right? And then I'm going to match a minus symbol exactly, right? So I'm saying, okay, now that I got some digit, now I want a minus symbol. Okay, now I need to do that digit thing again. And then I think I left out my minus symbol there. So that's should be an exact match. I'm sorry for that typo there. But it also should be able to tell us what the number was that got kicked out there. So the typo here should be plus minus after this second set of numbers here, right? So that would match all of so that's the 1, that's the 555, and that's the 1212. And we'll look at these in detail here and explain, but this is the high level idea. Question?
You have a range of numbers plus a range of numbers plus a range of numbers. It's implied that with the pattern, it goes on 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Yeah. Jackson is asking the same thing.
Yeah.
I think
this one's wrong. I chucked this one in there without thinking about it. We're going to go through this one in detail.
Yeah.
I apologize for the.
No, it's right if you finish it though.
Yeah.
Yeah.
But yeah, you're right. It needs the last four and it needs the other minuses in there to match. And so I probably is a bad example because we got to explain all this to make it work. But the high level idea is these things can get pretty cryptic. And so the questions we ask would be, does that match the entire string? Yes or no? And then the question is, does it match somewhere in the midst of all that text? And we'll look at all the different ways in which we can formulate those pieces of syntax there. And I will fix that one too. Okay, let's see if there's another one here. So here, yeah, okay, so here's the more typical, and again, the same typo. But here, the idea was you may not get a full match, but you might get a partial match somewhere within that text, right? And assuming that this was correct, that would actually work. So that needs to get fixed. So today, what we're going to do to get to know this language is we're going to play around with two replets. One is called pattern play. And this is where we'll choose a subject string, and then we will just iteratively change our pattern over and over again. Because a lot of times you're like, okay, well, I know I have some fixed subject, but I got to figure out what pattern is going to match. So this thing is set up to kind of let you iterate on that interactively. And then there's another one which just flips that. It's like, oh, okay, well, I know what I feel very comfortable about my pattern. Now I want to try out a bunch of different subjects to make sure that that pattern works on a bunch of different subjects. So it just iterates, lets you quickly change your subjects over and over without having to type in your pattern again every time. So those are the two things we'll work with. Let me load the file here. And so we have that for reference. 30 link. Okay, there we go. So these should be our links for today. I think I got it. There's not many, but we'll go through a lot of individual exercises to work on those. So let's take, and then we will look at the C++ code as well, but the main thing I wanted to get over to you today is an awareness or familiarity with the syntax here. And we'll definitely look at the C++ bindings, but a lot of the stuff that we'll do is just getting to know the language, because once you know the bindings, it's pretty straightforward to do. And the bigger task is learning how this thing works. So regex match, as we mentioned, is what we use to see if the regular pattern exactly matches the full subject string, okay? So if you've got something you want to know, hey, is this a phone number or is this a credit card number? You would use a regex match and you get a simple yes or no back, and that's pretty easy to do, right? So we just say something like this. We'd say our subject string is equal to some string, right? And then we create an instance of the regex class. So I've named it RGX, but you could call it pattern, whatever you want to call it. And then we feed it the string that we're searching for. So now is the winter of our discontent is our subject, and we're looking for the word our inside of that. And then we just simply ask the question, regex match subject against the regex pattern. If that equals false, then we didn't get an exact match. We might have got a partial match, but we didn't get an exact match against the entire subject. So that's kind of the top level routine that we would use from the regex library in combination with this instance of the pattern that we've created, right? So you can kind of see the pattern is kind of the persistent piece. We have to create an instance of the pattern in order to ask this regex match question, okay? So when we do that, we kind of get our instance right there. So I'm just moving some stuff off my screen. And then when we do the test, we're actually passing in that instance of the regex object to the regex match function, okay? Any questions on that? That's kind of the simplest question we can ask about the pattern and subject match. Okay, and this all comes from the regex library for sure, right? So let's try this a little bit. So I think you've got that regex pattern play link there. So that's the one you want to try, the pattern play one in your link file. So type in a subject string, right? So that's going to let you initialize it with a subject string, and then you can just test different patterns, right? So whatever string you put in first for the subject, then you can just iteratively try different patterns and see if you can get a match. So now these routines, so these the pattern play is going to execute both the regex match and then the regex search, which we're going to talk about in more detail here in a bit. So it's going to tell you two things. It's going to tell you, one, was it an exact match? So the answer for winter would be no, it wasn't an exact match, but it will also tell you whether the search generated a match somewhere within that string. And so the search should tell you yes, right? So you should see some search results. So try that, and you may notice also, it's entirely up to you. You can restart the REPL, or you can just type X, and it should allow you to reinitialize your subject and then iterate on the inside loop with a different pattern. So let's just give that a minute or two for you guys to play with, and hit me with any questions if they come up. And we will have an opportunity to look at the code. It's a little bit messy because of the way I tried to make it nice for your experience. So we won't go through all of the code just yet on those REPLs, but try some simple stuff. And if you know a little bit of syntax for the pattern, go ahead and try that too. If you want to try, you know, a range of letters or numbers, you can do that as well. Okay, I'm just going to put it on just a minute or two here. And this is the, again, this is the pattern play, which means we pick the subject and then we iterate on the pattern, which is just a byproduct of the way I wrote these REPLs. There's nothing really specific about it that's related to the way this stuff works in C++. It's just the way I built this replet. Oops. Ah, I see. Okay. There's one thing I made a change toward the end that if you put, I knew why I shouldn't have done this. If you put spaces in your subject line, it's not gonna execute correctly. So your subject needs to be all one contiguous set of text with no spaces in it. Apologies for that. That's a recent change that's kind of an unintended behavior. So you won't be able to put that phrase in there exactly as it was listed, spring, summer, winter, fall, unless you put underscores in it to kind of connect that all into one string. So sorry about that. But you should see if you do, you know, one long string for your subject, hopefully when you get a match, you'll see the little caret symbols identifying the area within your subject that actually matched. And we'll get to some more and more sophisticated patterns that we can test over time where that'll become a little more useful, I think.
Yeah, you can also do getLine.
Yeah, getLine would have been better. Actually, I switched it off of getLine and I should have left it on getLine. I think I was thinking, oh, this is old school. Let's move it to the new school. But the old school actually is not a bad way to go a lot of times. Okay, let's kind of move forward then and look at some different stuff. So regex search is, again, this is going to tell us if we got a partial find. And although we won't go into groups just yet, regex search will also give you back some additional information, as we'll see in a bit, about groupings. We'll probably come to that at the end of the lecture if we have enough time. So regex search is going to tell us if we found it somewhere within the subject, right? So yes, we found it somewhere in the middle. So there's a simple way to do that in code. So we have our subject string, we have our regex pattern, right? And then this time we'll run the regex search, and it's got the same kind of function signature that the regex match does. But all it's really telling us is if we got a partial hit on the pattern, right? So before we would have got a false for a regex match, but for this we should get a true. Again, unfortunately, I should have underscores here or fix that, that get line. You guys are free to do that if you want to make your own version of that, feel free. But same thing, right? We're just getting a Boolean back. It's helpful. It's a different kind of question. It lets us know if it exists partially inside of there. But we'd like to really know more. Like we'd like to know, okay, what did we find in fact, right? So in order to do that, we have to engage this. Oh, actually, I think I just have a little more information here that just reminds you that you could, do this indirectly. You could feed a string into the regex constructor, or you could put an actual quoted string in there directly. And you could also do it in line, right? So I could do a regex str inside of the regex search, and it's just going to instantiate that pattern at that exact moment. So in a lot of languages, it's a little confusing. JavaScript, I find, is like this too. You can either do it in line or you can create the pattern. And sometimes you wonder, well, why do I need to create an instance of the pattern? Can I just do it transiently like that? And you can definitely do that. That's perfectly fine, okay? So just pointing out that difference. So I think we're going to try the search here. So try this one more time and just make note of your pattern matches and see if you can get a partial match. I think you kind of did this on the last one, but let me just give you another match, another minute to think about the exact match versus the partial match as you go through this. And you can just try a different pattern. So same link, you can stay right in the same one that you were just doing there, and we'll just take a short minute. Let me just look over at one other thing here. Yeah, so we're still in the pattern place. We're just modifying our pattern against the chosen subject, and we'll flip that around here in just a minute.
So wait, how do we get the? My question is, how do we get the regex, like the string, the partial string back, and the Boolean? How do we get both?
That's where we're going to go next. So that's our next exercise. So we're going to look at an object called an S-match object, and the pattern play REPL you're using is already set up to do that. So, but we'll look at how you do what it's doing in code. I mean, you can look at that code, but it's got a lot of extra bells and whistles in there that is a little bit confusing. But we'll actually look in our PowerPoints here in just a second. We'll do a walkthrough on a simpler version that does all of that.
Good.
So let's jump into that. I imagine, and you guys can keep on playing with this. This is kind of more of a free-flowing lecture here. So regex search. So this is what we have to do if we want to get back some information about things that got found. So we still need our pattern. We still need our subject string, right? So now we need this other object called an S-match object that derives from, a base class that deals with matching of various kinds. So an S-match is a search match object, and it includes information that gets filled out by our regex search call. So we're going to pass in that SM object, and I believe it's going to be received by reference by the regex search because it's going to make changes to it. And then what we're going to get back from it is an answer, right? Whether we found something. But in addition to that, we'll find out actually, we can actually iterate through the item or through the SM and find out all the things inside of it that were found, right? So for auto item SM is that range-based for loop, right? So it's going to iterate, and it's probably overloaded because it's probably overload operators on its class. And we can actually just print out each individual item that's given back to us from that iteration, right? And those are going to be the things that got found. Now, there's a little caveat on that. Generally, you're only going to get one thing back. And it's going to be the thing that got found or the first thing that got found, not second or third iterations of things that got found. When we learn about groups here toward the end of the lecture, we'll talk about how you can get multiple things out of that. But the main thing that S-match gives us is the first occurrence of the pattern match against the subject. We can get that back and see exactly what that is. And we can't get it back without this, both using this S-match and the regex search function call. It's real. This is the part about regex that I don't like in C++, is just to get that basic thing back is kind of an annoyance. It takes a lot of effort to get it out. But these are the two things that we need, the S match and the regex, right? So regex search looks at this and changes the SM so we can iterate across the SM, okay? And typically the first thing we get back, it will be the only thing we'll get back that's useful, right? So let's take a look at a simple program that puts all this stuff together. So I have my subject and pattern, little prompt to the user to input that information, right? And should be a get line really. And then we'll do a regex with the pattern. So we have that instance. And we'll say, if we got a match, then go ahead and print out an affirmative thing, or otherwise let us know that it was not an exact match with the whole subject, right? And then we'll get our SM. We could do it like this, but as we saw, we can't really find out what the match looked like. But we can do this, right? Which we just saw, which would be the same as really doing that right there, the one that I just added, right? So we could just drop that, construct that instance on the fly. That's totally fine. And then if we found something, there are a number of things that we can do that, so we don't have to iterate. If we're just interested in what the first thing that was found, we just say smatch.str, and it's going to give us the string description of what got found, okay? And if you look in any of the code, the play subject or pattern play REPLs that we're working with today, you'll see a few more methods in there. There's a prefix that precedes the match string and a suffix that follows it that you can get out of there. But the main thing that you would pull out of that S match is the str. There's a whole bunch of methods on the S match that let you interrogate and find out things about that match. But this is primarily the one thing that we want. And then otherwise, if there was nothing found from that search, then we just say, hey, we didn't even get a partial match on that. That's kind of, I mean, other than the iteration across multiple, hits inside of a single subject, which is interesting, the rest of the bulk of what you need to learn to be a regex guru is really how to apply these patterns. It's really becoming a pattern guru or ninja for regex, and that knowledge is the part that transcends most languages. Once you really understand regex, you can do amazing things, incredibly powerful things. Like I said, you could write mini compilers using regex. Not that I would ever want to have to read your code, but it's entirely possible. But that right there is really kind of the meat of regex in C++. So what we're going to do is I'm going to leave this code view of this for a while. We're going to now dig into some of the semantics of this pattern matching to teach you just some basic things. But before I go, I want to see if anybody had any questions on this code here.
No, it looks pretty good to me. I usually have questions. That's why I'm saying something. Are we going to go into the other stuff that SM does? Because I saw more SM stuff in the code.
We might do that. I think the bulk of this lecture will take the rest of the time we have today for sure. And I don't want to take away from any of the finals review, but we may have some time on Thursday, and I wouldn't mind going through a little bit more of this stuff, because usually when I hit you with something for just one day, it doesn't stick. Not you personally, but I mean the whole.
Yeah, I got you.
So yeah, I wouldn't mind going into it a little more in depth on Thursday, but I thought I'd wait and see how people digest this stuff as we go. But it is pretty cool. There's some good stuff in here. Let's talk about then the language part, because and we'll go through some of this kind of quickly. I think some of you probably are familiar with this, but let's just kind of
one last thing, Professor.
Oh, your question? Yeah.
Yeah. Are we gonna get into replacing stuff, or am I just cutting you off because you're about to do that?
So replacing stuff, not so much, because I think that is sort of secondary to the regex. Like the regex will find the pattern, and then once you find the pattern, what you choose to do with it, I think, if I understand, the application is just kind of outside of regex, because you'll know where you found it and what it was exactly, kind of thing. But
yeah.
But let's circle back later on and make sure I'm not off base on that.
Okay.
Okay, so first thing we introduced up top, we have the way to represent options for multiple letters inside of some brackets. So that's one character right there. That's saying, hey, I want to match against one character that could be an A, B, or C. So it's sort of implicitly an or relationship between the letters you see listed there. You don't have to put any kind of an or statement in there. It sort of knows you mean it's going to be one of these things. So that's kind of a single character option that we start with, right? And it's easy to forget, especially if you come back to this and you think, oh, I want to match the letters A, B, C, and you think that's how you would do that. Well, that's not the case. That's at just matching one of those letters, okay? We could match one digit that way, right? And if we don't get a match, it's going to give up, right? It's not going to continue on. If the first part of a pattern does not match, it's not going to continue on and try to match the rest of the pattern. That's one thing about patterns. And I'm talking about the pattern here, right? So if you imagine sliding a pattern over the top of a whole text, long sentence, right? The first time the first part of the pattern doesn't match, it gives up, and it's for that particular match, and it won't continue, right? So if we have these subjects, A1, B2, C3, or D4, right, that pattern right there would match exactly against all of them. Why? Because the ABCD covers the first character, right? And then this covers the second character. So this is a pattern match that would exactly match any one of these subjects. And if these were buried inside of a really long sentence, then it would partially match with the search, right? So let's try that, right? So we're going to use subject play this time, which means you're going to enter your pattern first, and then you're just going to try out a bunch of subjects against that pattern. So we're just going to flip it around now. So put your pattern in first. You can put it in exactly like that if you like. And then try different subjects to see if you get the match that you would expect, right? And you can try, ones that you know will be bad, like you can have Z9 or Z1, and see what it says in terms of the match. Okay, take just a minute on that, and think about how you would change your pattern to support two digits, like A12 instead of just the A1, right? So I think you can probably abstract that away. So that, if you wanted to try that, just restart your REPL or hit X and enter your pattern again, and then type in your subject. Right. Yeah, and then you can think about what it would be like carrying that forward. This is a bit of a rhetorical question on the end here. You could try to support it for 10 digits, but it gets to be, as you will see, quite a nuisance to try to have brackets up there for 10 digits, right? So we're going to start to think about how we can automate that part of the pattern. But you can try it, do it 3 digits, then you'll get the sense of how futile it would be to have to do that every time. And of course, we'll see there's a solution for that.
I tried parentheses. I wonder what it is.
Do you say you tried parentheses?
Yeah.
Yeah, parentheses are special. Parentheses are groups. So as we'll see, but just sort of reaching forward, if you wanted to think of a pattern as being made up of a lot of mini patterns all together, then you can put the mini patterns inside of parentheses. So if you want a real parenthesis, then you have to backslash or lean slash to the left before the parenthesis to treat it like an actual parenthesis, not an interpreted character.
Yeah.
All right, let's take a look then. So that's kind of, there's our 2-digit solution for characters or digits 0 to 9. Now notice I put the 0 at the end here, so I'm explicitly listing these things out. They could be in any order that we want, right? If I do it this way. But we're going to see here with ranges in a second, we can also do like you might expect with A to Z, lowercase and caps and 0 to 9 for digits, we can do a range very directly, right? So here's our ranges, right? Very easy to understand. And if you recall anything about the ASCII character set, these are, directly in line with, with the ASCII character set, how it's laid out. Obviously, these are contiguous, so it's easy for it to understand what we mean here, right? So now we can do a pattern like A to D and 1 to 4, which is a lot more concise, right? So give that a try and see if you can do something like that. You probably still got your REPL up. And then try to, again, do multiple digits. And if you want to do multiple characters. And then when you do this, so we're still on this subject play. So you'll be iterating your subject. Try to create a longer string, like a double A and then a 1. And just see where the match starts. Or put a bunch of junk characters at the beginning. And then, for your subject, and it'll get to A. And that's where the match should start. Yeah. So give that a try. It's good sometimes to see how it fails in addition to how it works. And hopefully those little things that get printed out will give you a sense of where the match is happening. Give you another minute on that. Okay, so if we want to do lower or uppercase, you might ponder that a little bit and think, okay, well, how would I do that? I could do the A to Z. I don't think you can do a lowercase a to an uppercase Z. So how would we do an or relationship between individual characters? Pretty straightforward, as we'll see. So there is the solution, the pattern solution to that first question. We can kind of add that second digit with the range, obviously. But if we want to do or relationships, we use this vertical bar, right? Not to be confused with the bitwise or in C++, but since we're doing it inside of a pattern string that's being fed to the regex, it's going to be interpreted by the regex. So it allows us to do things like that inside of a single character specification. So we could say the A to Z or the capital A to Z for any single character, right? And if it's not in that space, then we'll fail at that part of the pattern match if there's more stuff coming, right? So anything like that, you can now match, you can imagine matching that by just adding that digit to the end. And notice again, we have the or inside of there, right? A to Z or A to Z. So we're matching a single character from either of those pools of characters. We would not put the or between the two sets of brackets there, okay? First character and second character. So let's try that, right? So we'll stay in subject play. So we're setting a pattern and then we're iterating on the subject. So start with this basic pattern we saw there and then try out a few different subjects and see if you can get it to succeed or fail. Kind of, again, remember there's two parts of these REPLs. They're testing the exact match versus the partial match, okay? And so, yeah, think about how you would go ahead and then extend that to 2 digits, which is, I think, pretty straightforward by now, but just make sure you're comfortable with how you would do that. Give you just a short time. It's a pretty easy one to do. Takes a little while to get used to the fact that a very large amount of code inside of this bracket really ends up mapping to just one character. Okay, maybe another half minute and we'll take a look at the next one. There's our pattern. I think most of you got that. Hopefully you're experimenting. All right, let's take a look at escaping. So there are many special characters that have special meanings, as we've seen. We've seen the brackets already, and now the vertical post. And one of them that gets used a lot that you can easily get confused over, perhaps because it's just so small, is the dot. So dot has special meaning that we'll learn about. It's a wildcard character. It's not like the star in Unix or Linux. It's the dot. Matches one wildcard character. But if we want to treat it like a decimal point, we have to backslash it or lean left slash before the dot, like any other kind of escape that we do. So backslash dot allows us to match against a specific decimal point, right? If we left it out, it'd be a wildcard. That's a source of a lot of confusion because it looks cleaner to just put the dot in there and think it's just a dot, but it's actually interpreting it as a special character, right?
Professor,
Yes.
what's a wild card?
Oh, sorry, wild card. Yeah, sorry. It'll match any character, any one character. Yeah, I don't know if that's just a really old reference that I got stuck with. So if you were searching for in Unix, you could have star, which would be like a list, files that end with .ppt for PowerPoints, right? Star.ppt. So it's anything, any number of characters followed by .ppt. The dot is any single character, not any number of characters. And we'll look at some examples.
Does a star still work?
No, star. Well, star has a very specific meaning, which we'll talk about. It modifies. It's a modifier, and we'll get to that in a couple of slides. But in this case, the wild card here, we're saying not a wild card. Like we're just learning about escaping here. But we'll see in a minute that the wild card is just replaced by any single match. So here's a couple examples. So all those characters right there listed are all special characters, right? So they all have very specific meanings. And so if we want to use any of those literally, like if we're literally looking for a caret symbol, we have to backslash the caret symbol or the dot or the brackets or any of that stuff. So that's just a heads up. If you find yourself using these symbols and you can't understand why you're not getting something to work, that's something we have to escape in order to make it work. So if we wanted to match something like a floating point number 2.3, we want to escape that dot because we want to literally match the decimal point. Now, true, we could just use a regular dot and the pattern might look for any character there, including the dot, and you might think it's working, which it would be, but it's not exactly doing what you're asking. If we put this in our pattern, then we'll actually match only the decimal point. So that would be a way right there to match a single digit, decimal point, single digit, okay? So that's kind of the literal decimal point interpretation. So let's try that. So go ahead and start. We're gonna be in the subject play again. So you'll set your pattern, or you can type X and reset your pattern. And just create some pattern that matches against a letter, number, an actual decimal point, and then another number. And then test that pattern out by changing your subject over and over again. So you're gonna set your pattern first, and then you'll try out a bunch of different subjects like A1.2 or B2.5, and even some subjects that shouldn't match your pattern. So give that just a try. And if you want, you can leave the backslash off, and you'll see that it does match these, but it would also match A112, right? It's going to eat whatever character is in there if you don't escape it. And that could get really confusing. You'd be thinking, why is it matching these things that are not really floating point numbers? And that's usually because we forget to escape the dot, the decimal point. Okay, so just take a minute or so on that one. And let's see if there are any other surprises there. Right, yes, it's going to look something like that, of course. Yeah, try that too. Try leaving out that backslash and see what happens. And if you put a few things in there that are not well formed, I think you'll see that the match shifts somewhere else entirely. A lot of times people talk about whether a particular control character is hungry or not if it eats something. So you can think of that. If we don't backslash that, that dot is going to eat whatever character comes after these first two parts of the pattern match. So it can give you something that you're not looking for. Okay. And then the kind of rhetorical question is, how would we deal with really long numbers? We kind of talked about this a few slides back. I mean, nobody wants to have to sit here and have some variable number of brackets following the decimal point. We all know that decimal precision goes on and on. And so how would we actually match those numbers more elegantly in our pattern, right? So there's the pattern solution for that particular one, but how would we kind of expand that a little bit? So we're going to talk about using these four special kind of characters, or this one right here is a collection of characters to control how many times we match something that preceded this character, right? So if we talk about something here like 0 to 9, and we wanted to do that some number of times, we would put the modifier here to the right side of that, right? So 0 to 9, how many times do you want to see a digit following the decimal point? Well, we can specify that in a variable way, right? We can say 1 or more times, or sorry, 0 or 1 times, 0 or more times, 1 or more times, or some specific number of times. Very, very terse and potentially hard to remember. So we'll go over this in a number of different slides, just so you can get an idea of how it works. So right, we don't want to have to kind of list those things out. So by following those things, we can control the frequency. So in a simple way, so let's take a look at question mark first. So if I said I wanted to match the letter B 0 or 1 time, right? So question mark has this weird and special meaning, 0 or 1. So that means I definitely want to have an A in my pattern. I can only really tolerate none or 1 B, and then I definitely want a C, right? So that pattern right there could match a subject that was an AC subject or an AB subject, but it couldn't match an ABB or an AD subject, right? And it's good to think about why. So AC has 0 Bs, so that's okay. ABC has 1 B, so that's okay. ABBB has too many Bs. We can only have 0 or 1 B according to this, right? That means 0 or 1. So that's not going to match. And AD is not going to match, of course, because we don't have the C there, okay? So that's called the 0 or 1 match, and it applies to the preceding character, okay? So let's take a look at 0 or more. So in this case, we could say, I don't really care how many Bs. I could have 0 or I could have more. I don't care. And that's what the star does. So here we get a match against the AC, the ABC, and also the ABBC, okay? And then we can apply those, and this is where they really come in handy, to these bracketed characters. So if I could say, hey, I want an X, a Y, or a Z 0 or more times, right? And that matches against all of these different permutations of those letters, okay? Okay, you can start to see some of the power here. And then similarly, the plus sign is 1 or more. So we kind of move from 0 or more to 1 or more here. So we're saying the B has to be there at least 1 time, but it can be there any number of times more if we want. And then after it eats all of the B's that it can find, it'll grab the C, and that will give you an exact match, okay? Or it will give you a match. But if that is my pattern, if A, B plus C is the pattern, that it has to match, it's going to only match something like that, right? You would not get a partial match with this against any one of these. You'd get an exact match against any one of these things, right? If the C was missing, you wouldn't even get a partial match, right? Because this would be our pattern, okay? So it's a little hard to see this. We'll practice it. And then this is probably the easiest one to understand. If we know, like in a phone number, and that my mangled phone number there at the beginning of the lecture, if I had just had the braces for the last one, that would work. I could also have had one or more of these guys, which would have matched each of the phone number clusters, because that would have covered the preceding one digit, the 800, which is 3 digits, and the final 4 digits, right? So that could have been a 0 to 9 plus, and that would have worked as well. But this lets us express exactly how many we want to match against, no more, no less, right? So this is kind of just talking about, this is giving you a visual to help you remember. So question mark is 0 or 1, star is greater than or equal to 0, plus is greater than or equal to 1. And then of course, this is just exactly whatever number is inside of that set of braces there, okay? So that right there covers a lot of power, but when you see this clustered in and packed in it, it can get pretty darn confusing. We'll see, just because it's very hard to read that stuff. So let's take a look at a couple more examples to kind of help you with that. We're going to again use the subject play. So we're going to set the pattern and then change the subject a bunch of times. So you can reset or start over. So we want to create a pattern that will match against subjects like these, right? Just any number of digits. We're going to just start with integers, no floats for the minute. So probably pretty straightforward based on what we've seen. So try to set your initial pattern that you think will match kind of an unlimited number of digits. And then go ahead and change your subject and try out a bunch of digits to see if your pattern works okay. Okay, so take just a short minute to see how that works. And then you might think about floating point numbers. If you want to try that and see if you can kind of augment that and consider, if you would, all of the complexities of how we can express a floating point number. We can have the preceding 0 dot something, or we can have a number dot number, or I could have nothing dot number. It starts to get pretty complicated, but you could try to match some simple examples and see how far you can get. There again, you just set your pattern first and then try a bunch of different floating point numbers against it if you want to try to do that. And we'll look at some solutions for that in just a second. Okay, I'm going to roll on here. So there's our kind of simple approach to matching any number. And then if we want to get a little crazier, not too much yet, but we can do any number of preceding digits followed by a literal decimal point and any number of following digits. Now, you should remember that plus is 1 or more. It's not 0 or more. So if we thought maybe somebody's going to forget to specify the leading integer, then we might want to have a star here for 0 or more matches. And then you could do a star here, but that could cause some problems because you could have someone just gives you just a dot and no numbers, and it might be interpreted as a number. So there's some things we have to do a little trickier if we anticipate people are going to just give us some bad data there, right? But one other very typical thing would be the sign, right? There's many ways that we could use or not use the sign, right? So if we want to find all the floating point numbers, including the sign, right? So we're going to have to consider using something like our 0 or 1, right? We know we're only ever going to have either 0 or 1 plus or minus in front of a number, right? Some people would put a plus in front of a positive number. Some people would just leave it off and it would be understood, right? So we can just set our pattern to be either the minus or the plus, 0 or 1 times, followed by a number, you know, however many times you want to match that. You can use a special character there if you want. So that's an example of our 0 or 1, right? So let's try that. See if you can, using the subject play again, see if you can get a match against positive and negative integers, right? So start with integers, see if you can get a match on that. And then if you want, see if you can extend that a little bit to floating point as well, right? I'll give you a minute on that one. Oh, sorry, somebody's in the waiting room. Gosh. All right, let's take a look then. So that is, right, so we can do the top one there. So that's our integer, of course. And then here's an attempt at doing floating point with plus or minus there. Right? And again, this is requiring one or more of the digits. So we can match, you know, a reasonably wide range, but we're still not dealing with the 0 or more case, which we'd have to change some things. Right? So if we want to make the mantissa optional, so here the mantissa being this part following the decimal, right? How would we go about doing that, right? So we're currently using the plus, right? So we can move that to 0 or more using the 0 or more pattern, right? So we would do something like that, right? So we're saying 0 or more of that instead of the plus on the on the right side, right? And then we have also, notice what we've done here is I've left off the sign for the moment, but I put the 0 or 1 of the decimal point. So I've made the decimal point here optional, right? Because somebody might just decide to leave it off and print the 1, right? Which would throw us a little bit of a curveball, right? So that gets us part of the way there, right? So play around with this a little bit and see how far you can push it. So we're going to be in pattern play this time. So we're kind of going to be iterating on our pattern because that's the part that takes the most work. So go ahead and switch over to this, the pattern play REPL. If you could see the link there. Here, I'll repost the links for the anybody who joined a little bit later. 1 second. 30 links. There we go. So yeah, look for the pattern play. I think that'll make it a little easier to develop it. So see if you can cover all of those cases. And you can type in, you know, a different subject if you want, but try your different patterns on one subject and see if you can kind of get it to match. You can add your optional plus or minus, and then some, you know, leading number, but possibly no decimal point. And you may want to leave your leading digit to be 0 or more there, the leading digit before the decimal point. That might make it a little easier. Okay, so here we'll look at that, just kind of accelerating a little bit so we can get through more of the material. So starting to look a little messy. You can imagine coming across one of these things in code and thinking, what is that thing, right? I mean, and that's just the beginning. One of the criticisms is it's just very difficult to document these patterns. You can do amazing things with these patterns, but they are really, really terse. Yeah, yeah. Yeah, I mean, this is why sometimes I think, people are very proud, to be ninjas. But, if you're working in a group with a group of other developers who may not be ninjas, it can be very onerous to try to pass along the knowledge to people. But it is really concise and very, very powerful. So definitely worth seeing. So let's break that down a little bit, right? So here is a number with plus, number, dot, right? So we're going to match 0 or more, 0 or 1 of the plus, right? There may be a leading 1. We're going to say we want 0 or more of these integers, and then 0 or 1 of the dot, and then 1 or more of the integers. So we're going to mandate that if you give us a dot, you have to at least give us a 0 on the back side of it, right? Right, like that. So that's not a bad match. It works pretty well, right? Okay. And we could do better, but that's just so we don't get in too deep with all of that. Any questions just on that stuff right there? That's kind of our first most complex pattern match. Okay, all right, bear with me then. We'll kind of see how far we can get here. We may have a little bit left on Thursday morning, but I'm sure you won't mind too much on having all this hit you over the head in one day. So this is a little saner, right? At least we can read it. Our eyes can read it a little more clearly. This tells us we want exactly four A's, or exactly 3 digits in the range of 0 to 9, which is very, very, very handy. So here's our phone number thing, right? So phone number kind of buried in the middle there. So we may want to extract some 1 or more digits, right? 0 to 9, right? But if we want to be really specific, we know that we're going to have a prefix, which is going to be 3 of the 0 to 9 digits, followed by a minus, which is not a special character. So that's going to match our 800, right? And then we could basically repeat that again and say 0 to 9 3 times, right? So that's kind of the hint for you. So let me see if you guys can, using the pattern play again, try to extract a number. You may just have to use the 800-555 number as is without that large sentence, since I kind of messed up the blanks in our pattern match REPL. But see if you can design a pattern to grab the phone number exactly if you just do the phone number. So in other words, if you just do this as your subject with no spaces, try to run your pattern to get that whole thing out of there, right? So if you use pattern play, you can put that subject in first and then try changing your pattern a bunch of times. So let's take a minute or two on that one and see how you guys do. Okay? So as you probably know, some European phone numbers use dots instead of dashes. So if you're trying to match against international data, you'd have to put in some kind of an or check there, which you probably can figure out how to do. Okay, so let's look at some of those solutions there. So the top one there is our kind of generic one for matching, maybe I guess you'd say a US-centric phone number. So I left off the leading 1, which we had on the first page. So it's just 800-555-1212, right? And in fact, that would should match any standard number that would come in that. Now, if we wanted to make it more international, we could change our minus to an or relationship. We can say, I would like to have the minus or a backslash dot. And remember, we have an implicit or relationship inside of these brackets, so we don't need to put that vertical stand or in there for those kinds of expressions, for those patterns, okay? So that's kind of our phone number thing, right? So let's take a look at another couple examples, a couple more here. Checking on time. Yeah, I think we're doing okay. So assuming month, date, year, this happens all the time, right? And you need to find a pattern match. Maybe you need to sift through and find a date in some text, right? We'd actually like to figure out how to match against that, okay? So our month and date values could be 1 or 2 digits, right? So we could make the first digit optional, 0 or 1 times, right? Or we could express a very specific number for the year, for example, because we, let's say we know that that is going to be always 4, right? So give a try with that, right? You can leave off the I will arrive on, since I have this little bug in my replit, and just try the 1/1/2019, and we'll do a pattern play on this. So again, we'll put in the subject and then play with the different patterns. You could actually do subject play if you want. Doesn't really matter, just which depends on which one you want to iterate faster. But see if you can get a match with your pattern for 1 or 2 digits for the day and the month. And as you can imagine, if you really, really wanted to be to validate a field, right? So field validation in a lot of text input for web input fields, you can certainly use JavaScript regex, for example, to see whether a particular date was entered properly. If the day was European, does the day come first? Does the day come second? And how large is that number? There's a lot of things you could do with regex to validate that if you want to. Okay, so give that a try. Oops. And see if you can extract the date from that or get an exact match against the date. Just give a minute on that one. Still got another 10 minutes or so. I think I can get us through some of the rest of the basic stuff here. Let's see how many more slides we got here. We probably won't get it all done, but that's all right. Another half a minute. Okay, yeah, so there's a simple approach to doing that, right? So we kind of get 0 or 1 of this first number, and then we ask explicitly for the next number. So we allow the first number to be optional. So if it's day, the day could go from 1 to 30, 31. And then same thing for the month. We could have a single digit number month or a 2-digit number month. And then we do our repetition for 4. We know we'll always have 4 for the year, but it could be 2 as well. So we could have done something slightly different there to be a little bit more flexible on that, okay? Let's look at another one real quick. Matching emails, another common thing, right? So we're gonna have to mix upper and lower case for each character, right? So we've got our ors inside of our ranges, which we can do for ranges, which is necessary if we're doing a range. If these were individual letters, we wouldn't need to do the or, but we need to do that for the ranges. And so that's going to get any one of those characters, right? And then we need to break this thing down, basically matching around the dot, and then potentially matching around the @ symbol, right? So those will be things that we will match against at various pieces. So give that a try. Maybe this will be our last one, I think. We'll do just a quick wrap up talk before I let you go. But go ahead and see if you can using the pattern play. So you'll enter your subject first, put in some kind of a pathological email there, and then see if you can't build a pattern match against that. So you can get a direct match against that, which would essentially allow you to pull it out of a pile of text as well. Okay. And you can imagine a lot of spammers use this one, trolling through large piles of text to try to pull out emails wherever they can, right? And a real common thing is to be able to try to get the domain name, right? It's like, okay, I need to have all the emails that I ever had or that people sent to me from a particular corporation, right? So that one's a little trickier. Take a minute on that one. Okay, I'm just trying to wrap things up here. So there's one solution to it anyway, right? So we have our very large set of ors, one or more times, followed by the literal decimal point, right? Which will occur one or zero or more times. It may be there or it may not be there, right? And it probably should be a question mark there. So it's 0 or 1 times, but you could have multiple dots, I suppose, in a row, followed by the A to Z and A to Z and 0 to 9 again, and our @ symbol. And then our caret, I don't know if we talked about the caret yet. I think the caret means only I think the last character in that string is what the caret means, I believe. I got to go back and check that. Apologies, I reviewed that one before we jumped into that. Whoops. But you can try that thing out. Well, I'll probably add a few more notes to that when we get together again on Thursday. But basically, this is kind of how that guy breaks down. If you wanted to look at the breakdown on that, you can pull down the slides to take a look at it. Okay. And then I think I talk about the ampersand or the @ in here somewhere, probably at the very end. I'll come back and add some notes to that because I'm sure that's a pretty powerful thing you guys will want to know about. I'm going to end it there just based on time. There's a few more slides that I wanted to go through, and then maybe I'll cover a couple topics from regex to wrap things up on Thursday. What would be helpful, and I'll send out an email to everybody who's still with me here, if you guys have any issues with question topics on the practice, the final exam practice that I put out today, or quiz 7, just email me and I can adjust our review on Thursday to spend a little more time on those topics. So I'll just kind of make it open season. If anybody has any topics they want me to cover, specifically ones that you're seeing coming from the practice exam or the quiz 7, the ungraded quiz 7 that I put out, let me know. Just send me an email on that and I'll go over that stuff on Thursday. So otherwise, I'm going to stay online. As you know, we got a week more on homework 9, but I'll be here, answer any questions tonight that you have. And otherwise, you guys have a good week and I will see you on Thursday.
Thanks, Professor. Have a good one.
Thanks, everybody.
Yeah.
Bye.
Hi, Professor.
Hey, oh, you're there.
Yeah.
Is that Dante? Oh, hi. I was
No, it's me.
typing to you. Yeah.
Uh,
Or is
Hi.
that Amadiel?
Amadiel, yeah,
Oh,
that's
hey.
me.
Oh, sorry. I got two people here. One second. One other person is there too.
I'm here as well.
Hi. Yes. Go ahead, Amadiel.
I had a quick question about the homework.
Yeah, yeah, Dante, you can go ahead.
Well, I was just curious how we're supposed to access the non-static members with a static function.
I just quick jotted a response, but I have to go back and look. I thought we were passing the mutex in, or am I remembering it correctly? I kind of bounced.
You're not passing anything in.
Okay.
Or you're passing 2 integers and that's it.
Okay. And are we? Okay. Let me check and see, because I did change that to static. I did change that to static relatively recently, but I thought I'll go look at what my solution was. But that's a fair question, because maybe that one I didn't anticipate. The other way was not static, but the syntax for doing it in a non-static way in the constructor was just terribly messy. So I will I'll circle back and get that here in just a second. I'll bring that up while we're chatting. I just got to go grab my solution on that. Mariel, how are you doing?
All right, how are you?
Good, good.
Yeah, I basically have the same question, because we are not able to use the non-static variables in the static function, so.
Right.
Yeah.
Okay, all right, so I might have botched that one because the other folks, I think, who had done it before did it with the non-static approach, which, I mean, you're welcome to do it that way if you want. It's just a terrible syntax, and some people were quite confused about it. But one second, let me get over to my REPL here and see what I did.
Yeah.
Just a sec. With me 1 second. Almost there. Boy. There's one of the other challenges with Replit is their file organization tools are not super good. Mark 9. HW9. Sign. Okay, there's. Bear with me.
No problem.
Constructor. That's interesting. I guess the oh, do I? Okay, maybe I don't have it implemented as static, or do I? Update health. Yeah, I think thought I'm looking for the full solution, but the only solution I have at the moment that I can find is the non-static one. But I swear I did it, but I think you guys are probably right. If I did it, I might have changed something about the health mutex in a way that made it accessible, maybe either globally or statically, and didn't copy that over into the updated REPL. So let me get back to you guys. If you guys have a solution in mind as a workaround and you just want to implement it, I'm certainly not going to mark off for it. So for example, if it works to make it static, that's, does that work actually? I don't know if you can make the
Yeah.
mutex static or not.
Right, but it's not only the mutex, but the boolean, game over boolean. It's also non-static, and we cannot use it in the static
Right.
function. Yeah.
Right. Okay. Well, the other approach, if you guys want to go back to the prior starter, which basically will work. It's just that the launch code for the constructor is a bit ugly. So, for example, I'm trying to pull that up real quick. I don't know if you guys had looked at that previously, but you can launch the thread with something like, let me give you this real quick. Give it to both you guys. So we can launch a thread that way. If it's a non-static thread, so in that particular case, you could just remove the static designation for the move boss function, and that particular launch will work. And then similarly, you could, let me give you the other one, just since I know I've been scratching your heads on this one. So the other thread launch would be like this for playtime. Sorry. And the weird thing there is we're passing in this, right? Usually we pass in the function. I don't know if you can see this in the text, but basically usually we'll pass in like the update playtime function immediately followed by the argument, which is the number of seconds to pause. But in this particular case, we have to pass in this context following that so that it can actually make a modification to that instance. So that was kind of the ugliness I was trying to help you guys avoid, but I may need to do an update to the class for that unless I figure out what my static solution was. Does that help for the short term? Otherwise, I think I'm going to have to take a look at that this evening and get back to you guys in email.
Yeah, I think that's it. Yeah, just change to static into just a normal void function, and
yeah. That's totally fine. Yeah, Dante, does that make sense to you?
Yeah, I think that's how I was going to do it, but I just was so confused because I was like, I'm pretty sure there's no way to get non-static functions into a static, but maybe you could do it through the thread, but I guess you can't.
Yeah. Let me look into that. And I apologize for kind of sending you guys on a wild goose chase. I'll have to get back to the rest of the class too, because I haven't heard anybody chime in about it. But my guess is most people are just waiting, and they maybe haven't gotten to it yet. But I might move everybody back to the previous way of doing it. Okay. All right. Well, that's a good one. I appreciate you guys bringing that up. Definitely.
And so our final is next Tuesday, correct?
The final is next Tuesday. Yes, at 6:10 p.m. I'll send out all sorts of reminders. It's going to be definitely online, and I haven't quite figured out what's the most practical thing to do in regards to Zoom. I feel like we should all be on Zoom audibly, so that at least we can have a text if somebody has a question, or if I need to announce something to the class, I can do it verbally. But I'll put those details out. But absolutely, the test will be online, and it won't be available until 6:10. And I'll have all sorts of reminders on that on Thursday.
and we're gonna prepare on Thursday, correct?
Yeah. So the idea was just to go through topics that people have troubles with. And, if I don't get much feedback, I'll just pick the things that seem like people are struggling with stuff. That can be a little tiresome for folks, if it's stuff that they are comfortable with, but that was the plan. And then, maybe a little bit of light wrap up on the regex stuff, but I think I've covered pretty much everything that's on the quiz and the final for regex as of today. So if you look at quiz 7 and you look at the practice for the final exam, the nature of those questions is really wrapped around the plus, the star, and the question mark kind of, and a couple other things about the regex syntax. So it's pretty generic stuff.
All right.
Okay.
Thank you.
You're
Okay,
welcome.
thank you.
Thank you.
Professor.
Thanks for letting me know. All right, I'll get
All right,
back to you
good
guys.
night.
Okay, good night. Have a good evening. Oh gosh. Okay, I can help you with that in a second. Yeah, it's a triangle thing. You can do the rind. It has nice spices on it, so you don't even have to peel that part off. I'm gonna start the grill.
Do the whole wedge?
Yeah. If you want, yeah.
I understand the silliness of this request, but can we find a new home for the cheese grater?
Oh, yeah. I think.
It's like I'm just short enough where I have
I'm
to
sorry.
really
It's-
grapple with it while it's
Yeah.
up there, which kind of hurts, and then I almost dropped it on my face, which was very scary.
Okay.
Oh, it's kind of stuck. Oh shit, really? Yes, it is quite old.
Do you want me to put it in here?
Oh, whatever.
Actually, let me reach it.
Haven't gotten that far.
Careful at the bottom. It's kind of.
Oh, okay, good.
Yeah, the shards came from the can, not from the thing. But I think it was because I was just doing stuff like that. You guys are awesome. Thank you so much. All right. This guy straight from the bag into the. Oh, and it's the smartest guy. He's the one who's. Oh, actually, he's probably. I think he knows exactly, and every time I'm wrong. So whenever I get something wrong, I hear from him. I don't think he's pointing out so much that I'm wrong, but I think he's probably half afraid that I'm going to give him a bad grade if he corrects my mistake without talking to me. Others.
This is like a weirdly challenging piece of cheese to shred.
Yeah, if you need to have a bit if you want.
Well,
However much you
this
think
is,
that
I'm probably at half.
it seems like
Yeah, oh, for sure, it needs a lot.
okay. Yeah, sorry, it's really hard.
It's more like the shape and the part of it has the spices on it, which I don't want to like take off with my
Oh
hands.
yeah, well, and don't cut your
Yeah,
knife. Okay. Well, I hope I find that I wasn't wrong, but I feel like I was sure that I made it work. I can't feel like it's impossible. So I'm not doing
It's okay.
Well, the hard part will be if there are lesser clever students utterly lost, like Zoe, and not. Mix it up. Wow.
Oh, is that the dough?
Really? Wow.
Where did he even get this?
I think you need it.
No, this. You saw the chilies here, right?
Chili soup? Oh. I was like,
Sorry.
outside, I was like,
No.
chilies are outside? Show some beers. Did you want it here? Maybe one of these?
I don't know.
These are
Like, I don't, well, I like the watermelon part, but I don't really like the wheat part so much.
What part?
The wheat part.
Oh, right.
Taste. So if someone enjoyed it more than me, then I would say save it. But if everyone's just kind of mad on it, then I'll take one.
Yeah, I think everybody's kind of mad. Probably. I think it's gonna be, the meat's gonna be done pretty fast. Andrew! Andrew, we're getting close. Okay. Let's see, so. Ooh. Front is always work. Yeah, if we don't eat this one. Just. Cheese.
I'm so. I wish I could have like been more thoughtful about this because the UCSC Games Showcase is open to everyone because there's so much space this year, or open to all alumni. So they sent out many emails about it, but only as of like 3 weeks ago. And I wish that I had something.
So you would have had an opportunity even though you already graduated?
Yeah, just put it in the showcase. Like it doesn't really get judged,
Yeah.
but it's just something for people to look at.
Wow, that would be cool if you could always come back and do that.
Well, you're welcome to like go back and work on the game for free on any game you want, pretty much, as long as they recruit you.
Yeah.
But of course, it's not a small amount of work, and it's not paid. So.
Salted lemons turned to mush. No, tell me about it. Salsa. Oh, I did get some salsa. You can use a spoon. You can grab some plates.
Oh yeah.
Go check the meats.
says I can submit my portfolio, which is kind of interesting.
Yeah, I mean, I wonder if it would be a way for you to just get more visibility around your work. Okay, bring in the meat. I'm gonna slice it, and then we're gonna eat.
Alrighty.
Correct. There's 2 beers in the freezer. They're probably not very cold.
What's that? Yeah.
I listened to so many dark podcasts today. I'm like a little overwhelmed by it.
You confuse the hell out of me.
Well, that's fair.
Yeah, it is.
Well, okay, I listened to My Favorite Murder, just one, but it was like, you know how they both tell one murder? They were both really dark. And one was like, it was like a McDonald's massacre in the 80s.
A McDonald's? Oh.
Yeah, a guy like came in and shot up a McDonald's and he killed like 20 people.
Jesus Christ.
And like the majority of them were under 30 and 5 were under 11.
Oh my god.
Yeah,
Oh, I think I know. When did this happen?
the 80s, like 86 maybe.
Yeah.
And then the other one, you remember the movie, what's it called? Like 3 Billboards in something? So that movie was based on these billboards that the writer saw once just driving by. Like he saw these billboards and he thought it was like an interesting premise. So he built the movie off of it. So this story was based off of those actual billboards and the real story that happened, which was equally disturbing.
That's cool.
Yeah.
No sci-fi. Can't watch any sci-fi. No.
Does that make you?
That's too realistic.
Listen, I'm sorry, okay? It's like the visuals and the delivery. Well then, okay.
I don't care how you deliver a mass murder in a McDonald's. It's a mass murder.
I wasn't prepared for it. I don't think I would have listened if I knew how dark it was going to be. But then, so I was like,
I knew more
okay.
than one person got killed.
I was like, okay, I've had enough of this. Like, I think I need to switch podcasts. I just need to listen to something different right now. Thing they had suggested was like, it's a podcast called The Honeydew, which is supposed to be a comedy podcast, but it's like comedy that like sheds humor on kind of personal stories and like trauma kind of. Trauma's a strong word for it. Like that's not really how they describe it, but just like bad happenings in the past.
Sour. That's on my list. Yeah.
But the reason it's called the honeydew is supposed to be because like honeydew is everyone's least favorite fruit in the bowl of fruit, and it always gets left behind.
Usually it's just crappy.
So yeah, so like that's what the name is based off of. So the guy that hosts it was doing his story, which was basically like his mom abandoned him and told him that she didn't want him, and like then all his remaining parental figures died in the course of like a year.
Jesus.
Yeah, it's like really dark.
Is that you or me?
It was you. But it's weird because his storytelling is like, do you remember that guy that has his own podcast on Parks and Rec? It's like something in the douche.
No.
You don't remember?
Oh, Daddy, that was you. Okay.
Was that me? Okay.
Yeah.
Like Fido and the douche.
No. that sounds horrible.
Yeah, it's like a really obnoxious guy. So he sounds exactly like that guy. And it's really hard to listen to. They're definitely smoking while they're recording it. And I was like, okay, like just give it a fair shot. And then it was just really sad.
Yeah.
So, and okay, but like here's the thing though, it's really hard to find stuff that's not about the pandemic. It's really hard.
There are probably so
all
many
of them.
things not about the pandemic.
I'm telling you, there.
Podcasts.
I know.
Period.
Yes.
Podcasts not about the pandemic.
Podcasts that aren't fiction, like just because I don't really like them as much. I tried a couple and they just kind of strike me as poor acting and not really as amazingly. I don't know.
What about the Bon Appetit podcast?
I have not listened to it. I didn't
Well,
know
that's
how
not. This one has malls in it.
Yeah, but like I don't know how much patience I have for like how much podcasts about food can I listen to?
Podcasts about murder can you listen to?
You watched a movie about people like eating other people, right? So
Yeah, but I don't avoid other.
Whatever. I'm not stopping you from watching what you want to watch.
What'd you say?
Do we have avocados ready?
No,
It's absurd. They're taking so long.
that's because I switched them.
Here, again? You switched them back?
Well, there's clearly a new one and an old one. The old one is quite close to being ready, but it was in the fridge, so it's
The
just
old
a
one
few
was
days
actually
away.
in the thing, which is kind of weird. Yeah, I pulled them out. It was,
Really?
Yeah.
No.
yeah, because when Daddy bought new ones, I was the one who unloaded groceries and put it in the fridge.
No,
and so
there,
I switched them
I
out, and I
swapped
put
it. No, I'm
You
sure
swapped
of
it.
this. I swapped it with an open bag that was in the fridge.
It's even bad. I would.
There was an open bag in the fridge, and what looked like an unopened bag sitting on top of the bananas. And immediately I was like, "That's not a good idea because we have an open bag, and if they're sitting on top of the bananas, they're gonna get ripe super fast." So I switched them.
Weird. I don't know what happened.
Comment.
So apparently someone was told by their study abroad advisor that all programs in Europe are canceled.
Oh, that's pretty
But
unconfirmed. Why would the
EAP?
why would the meeting not like why wouldn't they have the meeting that because they had a meeting and said we don't know, right?
Yeah.
Isn't that an official meeting?
Well, they said the university will make their decision by the end of May.
Yeah, but they shouldn't that shouldn't leak out to you guys accidentally.
Or it should just leak out to us all in the form of an email that
Yeah.
says it's canceled.
Is
That would be
EAP
the
just
education bar.
badly organized or something, or?
I feel like they've been handling the situation so poorly. Just
Yeah.
in the fact that they're not being transparent. Like, I don't expect them to know what's happening in the fall or
Yeah.
to make a decision yet, but they've given all indications that the programs are still happening.
Yeah, right.
And that is very irresponsible, and they've
Yeah.
given no transparency into how they're making their decisions. Yeah, there was a feedback survey, and I left some strong words. That was class. Last lecture, your last substantive lecture.
The two smartest guys hung around and to like kind of, I don't think they were trying to lay a trap, but they're like, so this thing that you told us that we should do, how it's possible in the homework. And I'm like, oh, well, you do this, and it's like, that's not working. I'm like, well, I'm sure I did it. Let me go check. And then I check my code. I'm like, oh. And I realize I'm gonna have to like tell the whole class to back up 2 steps because I basically told them to do something. But I was sure I got it working. And then I'm learning more and more, like when I come back to something and I'm like, oh, that doesn't make sense. I should just change that I shouldn't do that. Because usually that means I really tried and I couldn't find a better way. So that was a little mini downer, but.
Did you get any insight on the homework?
Yeah. I was like, I was annoyed with you guys today. I just want to let you know. And it was my fault because I realized the homework's not due for another week.
Oh, okay.
But I use it as a kind of a joke to be like, but also don't wait for another week.
Okay. That makes a whole lot more sense.
Yeah, because I gave it out 3 weeks early. I know. I poked it. I poked the bear. At least it wasn't the knife. Yeah, so they were nice about it. It was the two brightest guys. Probably the second brightest, because the brightest people already like just wrote around the problem by changing my code. These guys were like, we're gonna need to change your code. Okay, by all means, you're good.
All right.
Right, yeah. Not too much. Everybody's pretty subdued. Only 9 people today. So the usual 14, so definitely trailed off a bit.
To be honest, focus is getting really hard. It's getting pretty difficult.
Is it? Do you think it's because of the time at which you've been at home doing this, or?
It's just like because there's no differentiating between one day and the next. It just feels like there hasn't been progress, and we've kind of been in an infinite loop.
Oh, right.
You know what else I think makes a difference? The fact that your classes don't look different.
What do you mean?
Like, I mean, obviously not going to a lecture hall saves time, but like being in different settings.
Oh yeah, no, it's big.
I think spatial settings do build a framework for memory. Yeah, that's a really good point.
Blending.
Yeah. I try to think about visual metaphors that I can use to just give people, I use colors that way a lot. Like, okay, today orange is going to be this class and green is going to be this C++ class. And whenever we like have that, if you see this variable named green, it's going to be that instance. But man, it takes a long time to sort that out.
I am quite sure. You'd absolutely sell your electrics for like $50 a pop.
Well, and there's only like 4 colors that stand out, you know?
Yeah, I've always been frustrated with that.
So, what color are your backgrounds?
So my backgrounds are like a dark, kind of a cobalty blue. It's from a slide standard, you know, and they have kind of a design. So I kind of started there, but and I tend to use white text, but I've gravitated towards standardizing colors for like function names are in green, arguments are in yellow, comments are in gray, that kind of thing.
Yeah. I like what Sublime looks like.
Oh yeah, I may have to switch over to Sublime. Komodo's really starting to bug me. They've been bugging me for a while, really. I like those chilies. Do you try them?
I really like mine. Yeah, nice little flavor.
Oh. Yeah. Unfortunately, I started off the lecture with a typo at the very beginning, which bummed me out. Because, again, the smartest students are like, or the one guy is just like, I think he's a little spectrum-y, but I don't mind. He's always the one that comments on the side in obscure ways, and then someone else has to interpret. Like, I noticed this text while I'm lecturing, and he says, in quotes, "I think we're getting the music again." And then Ben, who's always not shy about asking questions, but is always just like he breaks in. He's like, "Professor, I think your microphone is rubbing against your zipper."
Oh.
But the guy, rather than say, "Hey, Professor, I think we're getting some microphone feedback," he's kind of sarcastically commenting on the side. It's like someone could just
like, what?
Yeah, I know. I didn't even know what he meant by that.
Also, like, who has the balls to do that?
I think
Like,
some
to a professor over Zoom.
some of these guys have a lot of balls, I gotta say. I mean, usually, I think some of them have had bad experience with teachers having a combative relation to teacher, and they expect me to be combative or somehow intimidated. I don't know. Certainly not everybody, but. But yeah, he's always a little odd. His comments are a little hard to read.
Is this the guy that, like, left you comments?
Yes.
Yeah.
Oh, okay.
He's the one who's
This guy seems weird.
He's a little odd. Yeah. Look, I think he's probably just being playful, but it's kind of hard to interpret. Oh. Yeah, I don't think I feel done yet, but I think that's
Emotionally, or are you talking about food?
Emotionally, like with the
Okay.
class. Like I thought I'd feel like relieved, but I think now that I have this thing I gotta fix, there's two. Oh, come on, I paused the recording. What the hell?